Okay, hello everybody. So today we're going to continue our discussion in Chapter 8, Section 3. And if you recall from the first video that we did in here, we discussed how to multiply binomials together. And there are two methods that I showed you how to do this, either the box method, which you can see there, or I showed the foiling method. And I did mention that the foiling method is probably the preferred method as you move through and move into higher math classes beyond Algebra 1. So what I'm going to show you today is some more examples of that distributive method, we call it, which is kind of, I'll say in class, it's FOIL with an extra oi in it. The reason being is this is more than just two binomials. And if you can see in this second expression right here, there are actually there's three terms in there versus only having two like there were in the other examples. Now, you can do this both ways. You can do this the distributive way, and you can do this the box method. I will show you both ways, but again, as you move through this, you probably want to get used to using the distributive method or the foiling versus the box method, just because it's kind of the more prevalent way that we do it as you move through into our higher level math classes. So let's get started. So we are going to take this x that's right here, and this x has to distribute to every single term in the second set of parentheses. So the x multiplies the x squared, the x multiplies the negative 5x, and then that x also multiplies that 6. And if it's helpful to draw arrows like you see me doing, then by all means do it. I think it's important to actually do that because I think it helps students not to forget to multiply all three things. So as I distribute that x through, x times x squared becomes x to the third. And then x times negative 5x becomes negative 5x to the second. And then the last one, x times 6, becomes positive 6x. So I took that x, distributed it to every term in the second set of parentheses. Now I'm going to do the same exact thing, but this time I'm doing it with the 7. And this 7 is going to distribute to the x squared and the negative 5 and the positive 6 in the same fashion. So 7 times x squared becomes 7x squared. 7 times negative 5x becomes negative 35x. And then 7 times 6 becomes 42. And there you go. So we've distributed everything out that we needed to. Now what we have to do is look through and see if there are any like terms that should be combined. And I will color code the like terms. You can see we only have one x to the third, so we don't have to worry about that. But there are two x squareds right here. There's a negative 5x squared and a 7x squared. And then there are also 6x and negative 35x. So those color-coded terms are like terms because they have the same variable and they have the same power or powers on the variables if there's more than one. So we will now put this in standard form, which is x to the third. Then we have negative 5x squared plus 7x squared. That turns into 2x squared because negative 5 plus 7 is 2. Then we have 6x minus 35x. So that will be negative 29x. And then lastly, we drop the 42 and just write plus 42. And that's it. There's your final answer. We foiled everything out with the extra oi in the middle, like I say, and we combine our like terms, and we end up with x to the third plus 2x squared minus 29x plus 42. So that's the distributive method. Now, you can solve this using the box method, but it needs a slight alteration. If you noticed up here, when we solved these, when we multiplied them together, both of the terms that we were multiplying together here were binomials, meaning each set of parentheses had two terms inside. So what that gives us is a 2 by 2 box, because we needed 2 boxes on top for that one, and we needed 2 boxes on the side for that expression. Well, if you look what we have here, we have 2 terms in the first expression, but we have 3 terms in the second expression. So we need to adjust the box that we use to account for that additional term in the second expression. So when we draw our box, we will go ahead and draw some sides here. Okay, now I'm going to draw a box, cut this in half like this, but then this other side, I'm going to cut it into thirds. And the reason why I'm cutting it into thirds is that I need 3 terms along the side. So let's see how we put this in now. So the first expression, x plus 7, we will put right here, x plus 7. But then the next expression, we'll put x squared for the first box, then negative 5x for the second box, and then finally, we will put 6 for the third box. So you can see we needed 3 boxes along the side so we can have a space for each of the terms in the second expression. Now we proceed to multiply, just like we did in the previous video. So first we start with x times x squared. That gives me x to the third power. Then we do x times negative 5x. That gives me negative 5x squared. Then we can do x times 6, which gives me 6x. Okay? Followed by that, we now multiply the 7. 7 times x squared is 7x squared. 7 times negative 5x is negative 35x. And then we have 7 times 6, which is positive 42. So now that we've multiplied everything, we can go ahead and write those things all out. The one nice thing about the box method, once you do multiply it out, you can look through it and find your like terms. So for instance, there's a 6x and there's the negative 35x. And then the other set of like terms is the negative 5x squared and then 7x squared. So we can combine those before we write them out, which makes it a little bit nicer. Start with the x cubed. Then we have the 7x squared minus 5x squared, which gives us 2x squared. Then we have 6x minus 35x, which is negative 29x. And then we have this plus 42. And so what you can see is we get the exact same answer. Either way, we multiply this out. So here's another example. Got 2 more examples for you. I'm going to show you the same exact thing. We'll show you kind of the distributive method, and then I will show you the box method. So the distributive method is just like we did before. We'll start with this y. It gets distributed to all 3 terms. So y times y squared is y to the third. Y times 9y is 9y squared. And then y times negative 2 is negative 2y. Following distributing the y, we will now distribute the negative 8. Keep in mind that when you distribute numbers, the sign that comes before the number goes with the number. So that negative 8 distributes to all 3 terms there. So we have negative 8 times y squared, which is negative 8y squared. We have negative 8 times 9y, which is negative 72y. And then we have negative 8 times negative 2, which is positive 16. Now, after we do that, we will go through and identify our like terms. In this case, we have a 9y squared, and we have a negative 8y squared. So both of those are like terms. Then we have negative 2y and negative 72y. So there are our other like terms. So now we order them from greatest power to least, so it's in standard form. So we have y to the third. Then we have 9y squared minus 8y squared. 9 minus 8 is 1. So we will put plus 1y squared. You don't have to have the 1 if you want to just put plus y squared, that's fine. Then we have negative 2y minus 72y, which is negative 74y. And lastly, we have plus 16. And there it is. There's our final answer. Using the box method, we can put, since we only have 2 boxes on the left-hand side, we have to put y minus 8 over there. And then across the top, we need to put y squared plus 9y minus 2 there. Okay, so now that we have those, we will go ahead and multiply. Y squared times y gives me y to the third. Y squared times negative 8 is negative 8y squared. 9y times y is 9y squared. 9y times negative 8 is negative 72y. Then we take negative 2 times y, which is negative 2y, and then negative 2 times negative 8, which is positive 16. So now that I have that all done, you can identify your like terms. You can see there's a like term here and here. The other place there's a like term is right here and right there. So there are like terms. We will combine them. Let's order the terms, though, by their highest power. Start with y to the third. Then we have 9y squared minus 8y squared. So that's going to be 1y squared. And again, you can write the 1 or you can leave it out. Doesn't matter. Then we have minus 2y minus 72y, which is negative 74y. And followed by that, we have a positive 16. And there you go. There's our final answer. Matches perfectly with the distributive method that we did in the first part. Okay, so the last one I'm going to show you today, just like the other ones, we'll start with the distributive method, then we will do the box method, and as long as we did everything correct, our 2 answers should match. So let's start with the 3a, distributes to all 3 terms like this. Okay, so we have 3a times a squared gives me 3a to the third. Then we have 3a times negative 12a. So 3 times negative 12 is negative 36. And then a times a is a squared. Then 3a times 1 is simply 3a. All right, so we've distributed the 3a. Now we will distribute the 4. 4 times a squared is 4a squared. Then we have 4 times negative 12a. So 4 times negative 12 is negative 48a. And then lastly, we have 4 times 1, which is 4. All right, so now that we have distributed everything out, we will identify our like terms. You can kind of see a pattern here, hopefully. You can see the a squareds end up having like terms, and then the a's end up having like terms right there. So those are the ones that will be combined. We start with the 3a to the third. Then we have negative 36 plus 4. That's negative 32a squared. Then we have 3a minus 48a. That gives me negative 45a. And then lastly, we can just include our plus 4. There's our final answer. Now the box method. Once again, the first expression, 3a plus 4, goes on the left because there's 2 terms. And then the second expression, a squared minus 12a plus 1, goes across the top. Now once we have that, we go ahead and multiply. A squared times 3a gives me 3a to the third. A squared times 4 gives me 4a to the second. Then we have negative 12a times 3a. That gives me negative 36a to the second. It's a little tricky. Remember, 3 times negative 12 is negative 36, and a times a is a squared. Now we have negative 12a times 4, which gives me negative 48a. And then we have 1 times 3a, which gives me 3a. And then we have 1 times 4, which gives me 4. And there you go. Everything is multiplied out. Now we will identify our like terms. I like to highlight them. Makes it easy for you all at home to see this. So start with the highest power, 3a to the third, then go to the smaller one. We have 4a squared minus 36a squared. That gives me negative 32a squared. Then we have negative 48a plus 3a, which is negative 45a. And lastly, we have plus 4. And that's it. We're all done. That matches what we got in the using the distributive method, which is great. Again, I don't mind. You can do it either way. It's fine by me. My preferred method is the distributive method, just because that will be the method you will pretty much use as you move forward in your math class. But for right now, it doesn't really matter. So that's what I have for you today. As always, if you have any questions, feel free to email me. Have a great day.